Hello dear students, I on behalf of EECC welcome you to the demo analysis of our demo mock test. The mock test questions, it has already been uploaded in our website, so you can see the website link and you please download the question first. Okay, so after downloading the question, there are few questions in the few questions on the question paper. You try to solve the questions yourself first. Okay, so after you solve the questions, you return to this video. Now, so now if you have already downloaded the question and try to solve it, now I'm going to present to you how we are going to conduct the mock test. Okay, see, in the mock test there will be certain questions. So what we are going to do in the analysis part is we are going to show you the answer. Okay, how the answer that has come from that particular question. Also, we are going to cover on that particular topic what are the possibilities of the question that may arise. Okay, don't worry about that. We are going to demonstrate how it will be done on certain questions. So anyway, what we will be doing is we will be supplying you the question. You appear in our mock test. Then once the mock test is over, we will upload the video in our app. The link of the app will be shared with you. Okay, it is our EECC online app. So once you are inside the EECC online app, you will be able to see the detailed solution or the detailed analysis of that particular mock test. In this test series, we will be conducting a total of 23 number of tests. Okay, there will be total 23 set of tests. Out of this 23 tests, there will be 16 subject-wise tests. 16 subject-wise tests. Okay, if you see the syllabus of your JE RWD, you can see that there are 16 subjects listed out. So there will be individual tests, keeping in mind the questions on the pattern of your APPSC RWD that is going to be conducted on 25th of April 2021. Then 16 will be subject-wise test. Then there will be 4 mixed tests. So when we say mixed, that means we are going to combine few subjects, let's say 3 or 4 subjects at one. Out of the total 16, we will be conducting 4 mixed tests. That means 4 subjects will be asked in each of these tests. Okay. Then the remaining 3 will be full length test. Full length test. In the full length test, it will be purely on the basis of your syllabus that is shared with you through the commission. And the schedule for this 23 tests, it has already been uploaded in our website. You can go on the website link and check it there. Okay. So anyway, so let's move on to the analysis of our mock test that is shared in the website. So let's analyze our question number 1. So in the question, if you check, it is saying when the plastic limit of the soil is greater than the liquid limit, then the plasticity index is reported as, the options are ABCD, negative, 0, non-plastic and 1. So it is said in the question, if the plastic limit WP is greater than the liquid limit WL, okay, WP is greater than the WL, then the plasticity index is reported as, the IP value is how much? It is said in the question. So the IP formula, plasticity index is liquid limit minus the plastic limit. Now if I am saying that plastic limit is greater than the WL, numerically, just for example's sake, if you are taking suppose WP 10 and WL, since it is a WP is greater, let's say 5%. If you solve this, 5% minus 10%, so numerically you are supposed to get a negative value, isn't it? So numerically you will get a negative value, but there is a condition that IP is a range. Range means it cannot be negative. So IP value, when you are getting the value as a negative, actually IP value can never be negative. It will be 0. When the soil is having a negative value, the soil is non-plastic, and hence the IP value is reported as 0. See, in the option number C, it is said that it is reported as non-plastic. So the soil is non-plastic, it is not reported as non-plastic. Okay. Next, what are the other conditions in which the soil is IP value is 0? So the first condition is if WP is greater than the WL, the IP value is becoming 0. Next, if there is one more condition when it becomes 0, if WL or WP can't be determined. If WL or WP can't be determined, the IP value is 0. That means the soil is non-plastic. So the question may arise in both the situations. If it is said that WL or WP can't be determined, your answer will be IP equal to 0. And if you are getting numerically IP value as negative, then also the IP value is reported as 0. So option will be 0 in this case. So let's check out question number 2. In the question number 2, you check the question. A combined footing is generally used when? So options are given. Number of column is more than 2 and they are spaced far apart. Second, number of column is 2 and they are spaced close to each other. Number C, number of column is 2 and they are spaced far apart. And D, there is only one column. C, what is the concept of our combined footing? When we use the combined footing, let's say we have our first footing, something like this. And if the second column that is coming over here, if this column is very close to this, so what will happen? The footings are going to overlap with each other. So when this kind of a situation is occurring, when two footings are overlapping each other, we do not provide the overlapping like this because it is physically not possible to be constructed. So what we do is, in that situation, we simply combine the footing. See, combining the footing means what? The reinforcement will run all the way across from one part to the other part. If you are constructing like this, that you have to construct a reinforcement here, hold this separately, that is not possible. So what will be the option? The option will be option B. Number of column is 2. See, number of column is 2 and they are spaced close to each other. When they are close to each other, like this. So in the first option, what they have given? Number of column is more than 2 and they are spaced far apart. So if the number of column is more than 2, let's say for example 3, here also they are combining with each other. Okay, it is similar to this only. But here there is number of column is more than 2. Then even though they are combining, it is not a combined footing. What is it? It will become our strip footing. Remember, okay, for a column to be, for a footing to be combined, there must be two columns and the footing, they must be close to each other. Then we are going to use our combined footing. What are the other scenarios in which you are going to use the combined footing? The second scenario is when the last column is very close to your property line. For example, suppose this is my property line. I want to place my footing over here. So if I want to place the column here, when I make the footing is going to encroach the neighbor's land here like this. So this is the land, this is the boundary of my land. So my footing is going to go to the neighbor's land or encroach it. So in that situation, what we are going to do, we are not going to construct this. Instead of this, in order to make it, we are going to combine the footing like this. So this is our first column, this is our second column. Then we are going to combine in the other side, something like this. So remember, there are two scenarios when we will be using the combined footing. First, when the two footings are overlapping, that means when the columns are very near to each other. Second, when the column is very close to the boundary line and the footings encroaching the neighbor's land or your property line. Let's take our question number 3. In the question number 3, see the question. The relationship between water content W% and number of blows N in the soil as obtained from Casagrande's liquid limit device is given by, so it is given water content formula is 20 minus log base 10, the value is N. The liquid limit of the soil is, the options are given ABCD. Now, I want to find out what is the, as per the question you are asked, what is the liquid limit, WL equal to how much? So if you remember or recall the Casagrande's test. In the Casagrande's test, what we do is, what is the liquid limit? As per the Casagrande's test, the liquid limit is the water content corresponding to 25 number of blows. That means whatever liquid limit you will get, when you put N equal to 25 is the liquid limit. So let's see. So if you replace this by 25, you will get WL is equal to 20 minus log base 10, so 25. So if you solve this in your calculator, you will get 20 minus log 25. So the answer will be 18.6. 20 minus log 25 is 18.6. So if you check your answer, it is your option number D. Okay, in the option number D, there is a 18.6%. Okay, so this is your analysis for question number 3. So let's take your question number 4. In the question number 4, see the question. In the most general form of Bernoulli's equation, P by W plus V square by 2G plus Z equal to constant, each term represent what? So the given equation is P by W plus V square by 2G plus Z equal to constant. So each of this term, we have P by W, V square by 2G plus Z, what are they representing? Actually, they are representing the energy per unit weight. Okay? So if you see, the option will be B, energy per unit weight. See how? So this term, what is it? It is the kinetic energy per unit weight. What is your kinetic energy? It is half mv square. If you divide this kinetic energy by unit weight, that means one weight. So divide by mg. Kinetic energy per unit weight, this will give us, so m and m will get cancelled, so it will be v square by 2g. That means what it is? This is kinetic energy per unit weight. Second term z, what it was representing? It is the potential energy per unit weight. So what is the formula of potential energy? mg into height. The height is, let's say, z. So again, if you are dividing by mg, if you are dividing by mg, so this will give us z. That means what it is? This is the potential energy per unit weight. The first one, the pressure energy is P, and if you are dividing this by the unit weight, rho g or gamma, it is represented here W, or they may give you gamma, here they may give you gamma also, here they may give you rho g also in this place. Okay? So each of this term is representing the energy per unit weight, and this is the pressure energy per unit weight, this is velocity energy per unit weight, this is the potential energy per unit weight, and this is also known as pressure head, this is the velocity head, this is the datum head. So whatever I am saying, write it down. Okay? So all of these things are very important for your exam, because in some, they may not ask you something like this. They may ask you, what is this term? This is the pressure head. They may ask you, what is this term called? If this is the velocity head. Or sometimes they will give you the velocity and they will tell you, find out the velocity head. That means you have to find out v square by 2g and something like that. Okay? Let's analyze our question number 5. So the question is saying, for laminar flow in circular pipes, the Darcy friction factor F is equal to which one? So if you remember or recall, Darcy with the formula, it is the head loss because of friction 4FL V square by 2GD. Okay? If you are considering this formula for FL V square by 2GD, what was F? F is the coefficient of friction. Okay? And if you are using this formula, the F value is 16 by Re for the laminar flow. For laminar. Okay? But there is the modified Darcy-Weisbach formula. As per the modified Darcy-Weisbach formula, the formula is F dash L V square by 2GD. And as per this modified Darcy-Weisbach formula, the F dash value is 64 by Re, and this F dash is your friction factor. Friction factor. So if the question is based on this, I mean the Darcy-Weisbach formula, you properly check what factor is given. If coefficient of friction is given, that means you have to use 4F. If friction factor is given, that means F dash is given. See, they are the same thing. The F4 value is here, the 16 is here. 16 into 4 is 64. Here the 4 has been eliminated and kept here itself, so it becomes 64. So here it is saying the friction factor, so it will be 64 by Re. If the question would have been coefficient of friction, then it would have been 16 by Re. Okay, so the correct option for this particular question will be option C, 64 by Re.
So the question of your demo mock test is displayed on the screen. A question is displayed on the screen. You can see the question. The question is saying that calculate the limiting length of offset if the maximum allowable error in laying offset is 2 degree. The scale of the map is 1 centimeter equal to 100 meter. The offset, the length of the offsets are given in the form of option. You can see the first option, it is 2.5 centimeter. The second option, it is 7.63 centimeter. The third option, it is 250. and the fourth option it is 230 meter. So here in the question, if you see, it is asking about to find the limiting length of offset. So the first thing is, what is the limiting length of offset? It is the maximum length of offset that is allowed on the field. So in order to solve this question, what I can do is, I can write the formula for solving this one. For the first question, I can write the formula. So the formula for finding the limiting length of offset is given as your L is equal to 0.025 into S divided by sine of alpha. This is the formula for calculating the limiting length. Now, here you can see that there is a alpha value. So this alpha actually represents what? It actually represents your maximum allowable error in laying of the offset. That is, your alpha is actually your 2 degree. 2 degree is your alpha. And the value of S is what? It actually represents basically the ground distance. That means you can see the scale of the map is 1 centimeter equal to 10 meter. So the scale is given as 1 centimeter equal to 10 meter. So here your S will be nothing but equal to 10 meter. So if you put this value here, then it will be L is equal to, in this proper equation, 0.025 into S, that is your 10 meter. Sorry, it's 100 meter. The question it is displayed as 100 meter, not 10 meter. So your S value will be 100 divided by sine of 2 degree. So if you solve this one, let me use a calculator in order to solve this. So if I put the values in the calculator, it will be 0.025 into 100 divided by sine of 2 degree. So I am ending up with a value of 71.63 meter. So I end up with this value. Now you can see in the option that the value of 71.60 meter is given in which option? Option number B. So this will be your answer. Now in the question, it might be asked like this particular value. So if in the question, if they are giving you that the maximum you can say permissible error on the plan is given as 0.03. Okay, so in that case, instead of using this 0.025, you have to use 0.03, because when we actually derive this formula for limiting length, there we usually consider that the maximum length, error that is permitted on the plan or map is actually your 0.25 mm. 0.25 mm. So this can be written as 0.025 centimeter. So this value is actually written here. You see, this value is actually written here. So if in question they might also ask that this value they might change. Okay, this value they might give that the maximum permissible error on the plan or map may be your 0.03. So in that case, instead of using this 0.025, you can use the value of 0.03. So this can be asked in the varieties of question. So this is how you can find the limiting length of offset. So the correct answer will be 71.63. Okay. Now let us move to the second question of your mock test. So the question is displayed on the screen. You see the question. Now let us try to find the solution. So in the question it is saying that the radius of the horizontal curve is 100 meter, the design speed is 50 km per hour, and the design coefficient of lateral friction is 0.15. Determine the rate of super elevation to be provided if the lateral friction is assumed to develop. If full lateral friction is assumed to develop, basically. So here you can see in the solution, the equation of super elevation is given as E plus F equal to V square by GR. This is the equation of super elevation. So in the question, your V is given as 50 km per hour. 50 km per hour. Or what you can do is, you can directly use your converted formula also in this case. But let us use your simplified formula. So this 50 into 5 by 18, I can convert it into meter per second. So it will be 50 into 5 by 18. So it is 13.88 meter per second. So your G, it is already 9.81 and your R value is given as your 100 meter. So your F in this case is actually taken as 0.15. So this F, they are saying that if full lateral friction is assumed to develop, that means the value of F will be 0.15. So if I put these values in the equation, it would be E plus 0.15 equal to V is your 13.88 whole square divided by G is your 9.81 into your R is 100. So you solve this one. So if you solve this, what you will get? It would be 13.88 square divided by 9.81 into 100 minus 0.15. So you end up with E as 0.0463. Now, if you see the option, then in the option it is given as 1 in something. So the super elevation, you have to, this value is obtained in your decimal point of view, right? So you have to obtain it in 1 in some form. So if I want to obtain this one in 1 in n form, then what I can do is I can simply convert this one. Like I can write this value as, if I write this one, it will be, I can write 4.63. I have put the decimal in backside, you can say 1 or 2 decimal. So 4.63 by 100. So here it will be 1 divided by 100 upon 4.63. So if you divide your 100 by 4.63, you end up with 21.5. So 1 divided by 21.59. So if you see the option, you are seeing that the option D is the closest one. That is given as 1 divided by 21.2. So your answer will be option D. This is how you can find the answer.
Hello everyone, let's take the examples and objective questions, okay? So the first question, if you look at the screen, is saying that the point where bending moment becomes 0 on a beam, or the point where bending moment changes its curvature is called. There will be a lot of options, okay? So to understand that, let's take this one. Say this is one beam. Say this is the beam. Now in this beam, say I am giving some overhanging portion. So these are the overhanging portion, and in this beam, say these are UDL. Say having intensity W kilonewton per meter. So length over is L. Okay. Say the overhanging portion is A and that is equal in both the sides. Now for this beam, if you draw the SFD and the BMD, you will find that SFD seems to be something like this. This could be the possible shape of SFD. Okay. Now if you want to draw the BMD, you will find possibly, because this is a relative diagram, as I am not considering the values, the BMD possibly could be something like this. Okay. Now you have to check the point where bending moment becomes 0. Okay. But mostly students get confused here. The point becomes 0 in a beam. This is not that point which the question asked. Okay. This is the point where shear force becomes 0. But the question is asking that the point where bending moment becomes 0 or changes its sign. Now this portion of the bending moment is in the negative zone. This portion of the bending moment is in the negative zone, and this portion of the bending moment is at the positive zone of the bending moment diagram. Now, if you look at this point, and this point, the bending moment becomes 0. Here also bending moment becomes 0, or I can say that the curvature of the bending moment from negative to positive changes, or here positive to negative changes. So these 2 points are called point of contraflexure. So never ever don't get confused that the point of contraflexure is a point where shear force becomes 0. Never ever do that. Don't think that The point where shear force becomes 0 is called point of curvature. No. The point where bending moment becomes 0 or changes its curvature is called point of curvature. Okay? I hope this is clear to you. Let's take another example. The next example, if you look at the screen, it is saying that if in a beam the bending moment wants to be maximum, on that point shear force need to be, the examples or the options are given to you. Right? Okay. To understand that, I can write these concepts. What does it mean? It means that the differentiation of the bending moment with respect to the length of the beam is equal to the shear force value, or the differentiation of the bending moment with respect to the length of the beam at a point of the beam is equal to the magnitude of shear force at that point of the beam. Now if you look at this beam, if you find the bending moment equation, say you are cutting over here and you are calculating the bending moment equation, and what you are doing the derivative of that equation with respect to the length of the beam. Whatever the value you will get, that value will be the shear force at that point. So this is my shear force at that point. Okay? So, as per the maxima and minima of mathematics, what is the condition to be for a polynomial becomes maximum? The condition is you have to differentiate something with respect to one of the variable, and that should result to 0. That means if my bending moment in this beam, there are a lot of bending moments. If you look at C, the bending moment is 0. Here, bending moment is this amount. So in a beam, there will be a lot of amount of bending moment. Now, out of all the bending moments, the point where bending moment wants to be maximum, on that point, this condition should be valid. The differentiation of bending moment with respect to the length of the beam should be equal to 0. Now, if you want to do that, ultimately, you are making forcefully the shear force value as 0. Okay? So, the point where bending moment wants to be maximum, say this is the point where bending moment is maximum. Say this is the point where bending moment is maximum. Now, at this point, what could be the possible value of shear force? Is 0. But, you have to understand that I am saying the point where bending moment is maximum, on that point shear force is 0. The point where bending moment is maximum, on that point shear force is 0. If this is also maximum, this is also maximum, or both are same, then only on this 2 point bending moment, the shear force should be 0. Say in this point, whatever the bending moment is occurring, in this point, whatever the bending moment is occurring is not maximum. This is the maximum. This is the point where the bending moment is becoming maximum. Now at this point only, the shear force will be 0. Now I am not saying that in every shear force 0 point bending moment will be maximum. This is not true. This is a wrong statement. If in a beam there will be numbers of shear force 0 point, on that every 0 shear force point bending moment will not be maximum. I am saying that out of all the bending moments, the point where bending moment becomes 0, on that point shear force must need to be maximum. But the point where shear forces become 0, on that point shear force need to be maximum. This is not true. The true line is the point where bending moment wants to be maximum, on that point shear force must need to be 0. Okay? Now you can take another example from the friction chapter. The angle of repose is a dash angle. Right? Options are say equal angle, say right angle, say minimum angle, say maximum angle. Now for that you need to understand first what exactly a angle of repose is. Now say this is one body, okay? This is one body and this is one surface. Now over this surface, if I keep the body, now the angle of the surface is how much? 0 degree. A horizontal line, angle of the surface is 0 degree. Now over a perfectly horizontal plane, I am keeping the body over here. Okay? Now, if I gradually increase the inclination of my plane, say I am increasing by 1 degree, 2 degree, 3 degree, 4 degree, 5 degree, 6 degree, 10 degree, still the body is in equilibrium. Why? The body, though the inclination of the plane increases to a maximum value, 0 to maximum value, but still the body is in equilibrium, that maximum angle of inclination of the plane, so that the body still remains in equilibrium by the assistance of friction only. That maximum angle is called angle of repose. The maximum inclination of a plane, the maximum inclination of a plane at which the body will remain in equilibrium, till the body will remain in equilibrium. Is there anyone who is applying a force to keep the body in equilibrium? No. Only the frictional force is responsible to keep the body in equilibrium. That maximum angle of the plane is called the angle of repose. Okay? Now if you look at this problem, which of the following sequence is correct? Right? Now if you want to choose if you need to choose the correct sequence, you need to understand this first. This sequence is very, very important in civil engineering field. And this could be understood if you learn the stress-strain behavior of any material. Say for example, I am taking example of Fe250. Okay? In Fe250 or mild steel, if you apply tensile or compressive load, then under tensile or compressive load, say this is one of the Fe250. Now on this Fe250 I am going to apply say tensile load. Now as we apply the tensile load, say the initial length is L. Because of application of this load, what will happen to the body? Body will undergo elongation. Once there will be elongation, there will be the development of the strain. Once there will be development of the strain, as the body is proper boundary condition, body will be developing stress. So if you want to understand till the failure of the body, the stresses and strain, how they will vary, the curve will be something like this. This is the curve. Okay? Now this curve can be divided into some sections. So this is OA, AB, CD, EF and say G point. Okay? Now OA is purely straight. Purely straight means the Hooke's law is valid. The material is given a load up to the elastic limit. So this is called elastic limit, or purely material is elastic, so this load will be called as proportionality limit. PL. PL means proportionality limit. Within this there is a proportionality limit. Okay? Now after that, up to the B, stress will not be equal proportional to the strain. From O to A, the load was such an amount given to the body where stress was proportional to the strain. So Hooke's law was valid. That's why up to the A it was proportional limit. But beyond the A, body will be somehow elastic, but stress will not be proportional to the strain. So up to B, body will be just elastic. But Hooke's law here up to OA, Hooke's law was valid. Hooke's law valid. But in the portion AB, Hooke's law, here in this portion AB, Hooke's law not valid. Because body is somehow elastic, but the stresses and strain are not proportional to each other. Up to C, the body becomes yielding. Okay? Now the zone CD we call yielding. So after proportional limit, whatever if you are going to increase the load, body will face the final elastic limit. After that, body will face the yielding zone. Then the D portion, this D portion we call plastic zone. And at the point F, the ultimate stress develop, ultimate stress or the ultimate point. It is the ultimate point, it is that ultimate means the maximum stress will develop, and at the point Z, failure will occur. So now you can easily detect which sequence is the correct sequence. Sequence is, first the body must face the proportional limit if the Hooke's law is valid. If the body is somehow elastic, first he will face the proportional limit, then he will face the elastic limit. Where the Hooke's law will not be valid, here Hooke's law valid, here Hooke's law is not valid. Here body is elastic as well as stress and strain are proportional. After that body will face the yielding, then plastic, then ultimate, then failure. So now you can choose the correct answer. Okay? Let's take another example. Now in this example, here saying that if concrete is not fully stressed, but at that time still has fully stressed. So what kind of section it will be? If you understand that, you need to understand this concept first. So this is one section, so the size of the section is B into D. This is the question asked from RCC structure, okay? Now, the quantity of concrete will be, if it is RCC beam, if it is RCC member, the quantity of concrete is B into D, or the cross-sectional area of concrete is B into D. And in this section, if I provide some amount of steel, say the area of steel is AST. Now, a section will be called as a balance section if the quantity of concrete and quantity of steel is provided in such a way that the stress developed in the concrete and stress developed in the steel is simultaneous and they will fail at the same time. That means if this beam is made of say M20 concrete and Fe415 steel, then concrete will develop maximum stress of 20 Newton per mm square. Right? Isn't it? And the steel will develop maximum stress of 415 Newton per mm square. So if the maximum in the concrete will develop 20 Newton per mm square, at that time if the stress in the steel which is 415 Newton per mm square, at the same time the section will be called as a balance section. Okay? Now in case of balance section, this could be the possible stress behavior or stress variation along the cross section where concrete has developed maximum of say FCK and steel has developed say F1. Okay? Now, this is only possible by adjusting the quantity of concrete and quantity of steel for a balance section. The quantity of steel and quantity of concrete is balanced in such a way that the stress developed in the concrete and in the steel will be simultaneous and they will fail at the same time. That means both the maximum stress will develop at the same time. Now compared to the balance section, if you reduce some steel, then whole will fail fast. If you reduce, compared to this balance section, if you reduce 1 or 2 bar from here, then in case of balance section, they will fail at the same time. But if you reduce the quantity of steel from the balance section, then the steel will fail fast. Isn't it? That means if steel will fail fast, then stress diagram will have something like this. Stress in the steel will be, say up to this only stress will develop. In steel, stress will develop this much. So at this level, stress will develop in the steel will be maximum because the steel has reduced. And the concrete will say that I will have much stress to be developed. So this will be the possible stress strain curve. So once you will reduce some quantity of steel will develop the maximum stress fast. He will fail fast, but concrete will say that I have more capacity. It means what? The 415 Newton per mm square of stress, if you reduce the steel quantity, it will develop before the development of the maximum stress in the concrete. Because you have reduced some quantity of steel. So it will be under reinforced section. Now if you are increasing the quantity of steel compared to the balance section, whatever the amount you have provided to make the section balance, in that section if you add some quantity of steel, then who will fail first? Concrete will fail first because steel quantity has increased. So once concrete will fail first, then concrete will develop the maximum stress fast. But steel will say that I have more capacity to develop. So at that time, concrete will fail fast, steel will say that I will have more capacity. So this kind of section is called over reinforced section. Now name says that under reinforced section means the reinforcement hand is reduced compared to balance section. Over reinforced section, that means reinforcement quantity has been increased compared to balance section. So now you can understand that if concrete is not fully stressed but still has developed its maximum stress, section's name will be over reinforced section. Sorry, under reinforced section. Okay?